Hi everyone, welcome to the 19th annual group exhibit of hydrogen and fuel cells at HANNOVER MESSE 2013. I invite you to please come and sit down and have a coffee and tea and explore our next discussion, which is accelerating the shift to reality of Germany's Energiewende. I will be speaking with Hydrogenics, with Dr. Bernd Pitschak, who's the Managing Director of Hydrogenics. If you could please join me in welcoming him to the stage. Thank you.
Hey, thank
Hello.
you.
Thank you. So perhaps you can begin with the history of Hydrogenics, where Hydrogenics is located, and go into a bit of detail about the products and the industrial applications of your products.
Yeah, thank you for that. Hydrogenics was founded in 1995 in Canada. It's a Canadian-based company headquartered in Toronto. It's a corporation listed on the Toronto Stock Exchange as well as on the NASDAQ. And we have, beside Toronto, two major production facilities. One is located in Belgium, very close to Antwerp, and the other one is located in North Rhine-Westphalia, Germany, in the northern part of the Ruhr area in Gladbeck. And our product ranges two main product lines. One line is electrolysis, so hydrogen generation, and the other line is fuel cells, PEM fuel cells. Today we want to concentrate a bit on the electrolyzer side, and we're coming from the industrial use of hydrogen, and you use electrolysis to produce hydrogen on site where you don't have a good supply line of industrial gases available. So typically our installation in the industrial areas are found in remote locations like Patagonia, Siberia, in the Middle East, in the Arabic areas, as well as in Australia, for example. Therefore, they are suited for heavy environmental implications, high dust, high temperatures, or very low temperatures.
So as there's a lot of individuals from all over the world here at HANNOVER MESSE, perhaps for some of those that might not be aware, can you please go into Germany's mandate in terms of the climate protection target and go into a little bit of detail of that?
Yes, I don't want to mention concrete figures, but in Germany we have agreed to the Kyoto Protocol, and by that agreement we also agreed on certain CO2 reduction targets for the years 2020, 30, 40 and 50, as well as on the amount of renewable energy we would like to add to the electricity generation. So the figures are for 2020 about minus 40% CO2 reduction and 35% renewable energies contributing to the electricity production, and then going further of 50% CO2 reduction on 45% renewables. So these numbers require that we adjust our electricity generation system CO2-wise, as well as of the source we produce the electricity.
With regards to meeting those targets, how is Hydrogenics involved, and how are you helping companies achieve this reduction?
In electrolysis, we see a source of producing green hydrogen, which can be used for various processes afterwards, and you can run electrolysis with renewable energies. So you produce CO2-free gases, in that case hydrogen, and we have entered that field back in 2004, not having the German Energiewende in mind, but we saw remote communities who were relying on fossil fuels, which were extremely expensive for them as they were remote, like an island in Newfoundland which paid more than $10 per liter of diesel to run their diesel gensets to produce electricity, and they started to transfer to alternative fuels, and hydrogen was one of it. So we ran hydrogen based on wind electricity and fired then CHP plants with the hydrogen that was cheaper than running on diesel. And from that idea to supply good energy to remote locations, we moved on to what is today called power to gas. And when the Energiewende took place, especially post Fukushima with a big push, we had already a lot of experience in units you can use to bring it to the Energiewende.
For those who might not understand power to gas, do you want to explain the basics of how it works and how it can be integrated into a system?
Yes, power to gas has become a wording for a certain process, and what power to gas means, it is a shift of energy from one, if you so like, grid to the other grid. We have electricity, and when we have surplus electricity available, given to heavy wind flows or a lot of sun available, and we don't have the demand for the electricity we produce, the so-called surplus energy can be transferred into the natural gas grid. And by doing that, we bring electricity into the gas grid, and then the gas will be distributed and can be used to generate electricity again at a different location at a different time. And to do so, you have to transfer the electricity into the gas grid by the use of electrolysis. So you produce hydrogen, inject the hydrogen into the natural gas grid and distribute it. You can also add methanization to it, then you have synthetic methane, and you stay in the natural gas world. But this is what is basically understood under the expression power to gas.
In terms of the renewables, there's been a lot of talk about the fluctuation of energy and a lot of difficulties with dealing with that. How has Hydrogenics been able to cope with that, and do you actually find difficulties with the fluctuating of the renewables?
That is a very good question, and we have been often asked in the past, can you handle this fluctuating energy input with the equipment? And in 2011, we performed a test in Ontario with the independent electrical system operator in Ontario, that is the transmission grid operator there. And we said, okay, we have an electrolyzer here available. Let us qualify for control energy. And we got a signal from them as an input on a second by second base. And the electrolyzer had to follow that signal over the course of 4 or 6 weeks. And after that course, we did an analysis with the ISO. And at the end, we had been qualified to supply frequency regulation. That is the highest source of control energy. In Germany, it's called Sekundenreserve, and the electrolyzer showed that it is able to perform that. And for us, it was a very good proof that we can now go out to the field and claim, yes, you can do control energy with electrolysis. Here are the figures. We can prove by heart.
Okay. With respect to the hydrogen, what are the limitations involved with injecting the hydrogen into the natural gas grid? Do you find there are any limitations?
Yeah, there are limitations today. There have been several studies performed what could be the maximum content of hydrogen in the natural gas grid. The reading as of today is that single-digit percentages of hydrogen injection in the natural gas grid is possible. No problems with that. For the future, it's foreseen that up to 15% of hydrogen can be in the natural gas grid. It sounds unusual, but when we go back in history to the mid-60s, we had a gas which was called city gas, and that city gas had a content of up to 55% of hydrogen. And then we transferred to natural gas in the 70s and improved that in the 80s and so on. So hydrogen in a gas grid is not something we have never seen before. Now, today, we of course set up to natural gas, so you have to do some adoptions, but it's absolutely technically feasible, and 5% concentration in the natural gas grid today is absolutely no problem.
Earlier, you went into a little bit of detail about your demonstration projects. Has there been any recent news or developments regarding any of these demonstration projects that you would like to share with everybody today?
Yeah, there were 2 news over the course of the last 6 months. Probably you have heard already from the E.ON Falkenhagen project, which is the first 2 megawatt power-to-gas project in the city of Falkenhagen in Brandenburg, Germany. That's a little bit west of Berlin, where E.ON sets up a 2 megawatt electrolyzer plant to produce hydrogen using surplus renewable energies and direct feed in that hydrogen in the ONTRAS gas pipeline. We supply the electrolyzers and the compression system for that. And yes, on Monday we announced a new project together with E.ON and other partners. It's that we have to deploy a 1 megawatt PEM electrolyzer for power-to-gas application also to E.ON. It will be installed in Hamburg at E.ON Hanse and will supply the hydrogen to the distribution network of Hamburg.
So moving forward from that, what can we expect from the future, and what are the goals moving forward from that project?
First of all, we have a product which can be used in helping to balance grid instabilities. We can produce a green gas which can be used in various applications. So we have a tool, and that tool can be used, but to use it in an economic way, regulations have to change over the course of the next, hopefully 12 months, to show better business models, clearer business models. Today we search out the technology and prove the concept in a larger scale, which is an absolutely necessary step to have products available in a year or 2 years from now when it is really needed to bring them to the grid.
At this point, I'm welcoming the audience to ask questions. Does anyone out there have any questions for Mr. Bernd Pitschak? Okay. Oh. Let's start with you.
You're doing both PEM and alkaline electrolysis. What are the pros and cons of the two technologies?
Oh, that's a very good question. It's not so easy to answer. Alkaline is a very stable, robust system. It's in the industry for 60 years and even longer. It has been built up to multi-megawatt systems as well to smaller systems. It's so-called the industry standard, and it will be there for a long time. I'm pretty sure and confident about that. PEM as a new technology offers you a tremendous reduction in the size of the stack itself. If you take a PEM electrolyzer and you look just on the stack will be 30 times smaller than compared to an alkaline stack. The rest, the so-called balance of plant, supplying the gases and taking on the gases, of course, is the same size as in an alkaline, but the entire system is a little bit simpler to set up, and therefore it promises to have larger cost reduction potential than alkaline. It is even faster in response than an alkaline system, but an alkaline is, as I have shown, fast enough already, and you have a very high potential for overload in PEM systems, so the pole curve is larger and wider than in alkaline. That gives you another degree in freedom in setting up the system itself.
I would like to ask you about the main hydrogen safety challenges that you face, whether on the level of injection in the natural gas grid or in remote applications. And could we say that today the challenges are overcome, for example, totally? Thank you.
Yeah, thank you for that. Hydrogen safety has been an issue since I'm in hydrogen, so back in the late 90s. Mainly it has overcome, I have to admit. All the installations we do today, either on the industrial side or for power-to-gas applications, following the codes and standards, the typical safety functions, and it's a no-brainer. You can install it in a typical way, and it's standardized already. So safety is a topic as in every industrial application, whatever it is, electrical, natural gas, gasoline. Safety is always an issue, but it's clearly understood, and if you follow the codes and standards, safety is achieved.
Any other questions out on the floor? Okay, I think that brings us to our conclusion today. If there are any further questions later on, please do visit the Hydrogenics booth at C59. It's just right over there. Yeah, it'd be great. Thank you for joining me today on stage. Appreciate your time.
Thank you very much.